Right, so today we're going to do a lot of practical things, and we're going to dig into two quite recent libraries. Now, I was not really particular in doing a lot of case studies with the earlier library because they've been classic and they've been around for too long. But let's have a look. What are the new opportunities? What are these two new libraries offer us? Right. So let's have a look. We're going to use two new libraries. We're going to use tidygraph, right? So first of all, what I want you to do so that you are able to follow me, can you please install those packages in your RStudio? So you need to do install packages, and these two you already have installed. And can you install gggraph and tidygraph? They are quite recent additions, and they provide a lot of flexibility. So gggraph is really a fantastic library because it introduces grammar of graphics. So if you're familiar with ggplot, if it introduces ggplot into the graph world. And ggplot is one of the jewels of R. So this is why people sort of switch to R, just because they want to have the flexibility in visualizing things, in plotting things. Can I just 1 second? So Jason, you're pointing out one thing. Just like you need to include one.
Maria, I've answered that one. Yeah, I mean,
yeah, I'm just
yeah.
So which line is that for you, Jason? So these
get your R markdown, and even though I'd installed the packages that we were
no, you have to it's like just extra line, just add extra line, or just see if I can push it.
I've installed them now. I just thought it might take a long time because sometimes
no, you don't. Yeah, well, you need to, you will be installing them. So you'll be installing all the new packages as we go. So that's why I suggest don't run that file, just follow in the chat.
I didn't run the file. It gave me a warning at the top of RStudio. So it detected that I needed these packages.
Yeah, what I suggest, right? And that's a suggestion to everyone, right? Installing those packages will take time. Don't install them now, right? We're going to install them as we go, right? So at this stage, you just try to do one step at a time rather than just run that's why I was not really that it's not really convenient if you run the whole file yourself now. So can you just slow down a little bit and just take one step at a time? That will be much easier with installation rather than just installing all of those packages yourself. So what I want you to do at this stage, I just want you to install gggraph and tidygraph, right? So let's, so this is the line that I want you to have. You already have your igraph and you already have your statnet. I just want you to install gggraph and tidygraph. These are the ones which were included in the welcoming email, so you may already have them installed if you follow that. Right now, the GitHub link is at the top, but just let me put that again. So that's your right. So that's the GitHub link. Right, and you're welcome to follow along. But I will be posting every single code in the chat. So can you all please make sure that you install gggraph and tidygraph, and we'll start looking into them, right? Now, what is so particular about these two packages? So these two packages are a recent addition by RStudio engineers, and they try to implement tidy workflow, not only into plotting, not into general modeling, but into the network science. So the idea behind tidy workflow and the idea behind tidy data is that we have a special way of how our data is organized. This is important because those nice principles of organization of data, when every line is a case and you've got all your variables over there, doesn't really work when we start looking at the graph, just because of that not really flat structure of our graph. But at the same time, we can borrow the tidy data workflow. and we can try and see how we're going to implement it. So tidy data workflow, which are really promoted by RStudio, is includes 2 steps. So we import our data, whichever format that is. So in relation to our graphs, that may be the edge list, or that may be the node list, edge list and node list, or that may be adjacency matrix, or it may be any other graph object that you can use. Then we're doing some tidy work. Tidy, when we refer to tidiness, we're thinking about preparation of our data. So if we are working with our edge list or nodes list, you remember the French train example, we did some manipulations to actually get the edge list, because you not always have the edge list and nodes list in your data. And this is where you have to do some manipulation with the data to actually get either adjacency matrix or your edge list. Now the next step, so once you're ready, so you create your graph object, and now you start your cycle where you transform your data, you visualize your data, you model your data, and you go in cycles until you're quite happy with your results. So once you're happy, you can communicate that to your final stakeholder, right? So you write your research paper, you write your report, or you just present it to your marketing agency. So problems here, we have so tidy, so we can manipulate that, so we can prepare our data, but now transforming our data. So once our data is already in the graph object, it's quite difficult to change that easily. So yesterday we were looking into how we can add edges, how we can add attributes. But what if we need to do a little bit more complex manipulations? What if we need to filter our data, filter our nodes, filter our edges? So how we can do this? How we can create communities, right? How we can cluster our data? So this way it becomes a problem. And again, visualizing our data is also quite challenging, if you remember. So we looked at several data sets, and our Florentines family was quite a small data set, and it looks awesome. But you remember the French train data was all over the place, and it was quite messy, with all, like, you know, just really all the edges and all the nodes, just like as above, not really visible to the final user. So how we work with this? So especially with large data sets, modeling part may not really be that challenging depending on what you're doing, but the biggest focus for these 2 packages is on data transformation and data visualization. So gggraph as ggplot, but gggraph, trying to apply principles of visualizations to graphs and try to use layers to make it easier and more convenient for us to work with different layers of visualizing our data. When we look at transformation, we are going to use tidy graph, and that's the second part of it all. So how we're going to manipulate our graphs? How can we apply the general principle? How we can apply the general principle of tidy data and dplyr, if you're familiar with that, to the graph. Guys, I'm seeing that somebody having issues with the audio. Are you all able to hear me? I charged my AirPods, but I still have some noise coming from the street. But yeah, so can you hear me? All good?
I think it's only Aga who lost the audio, Maria. Everyone's all good.
Okay. Oh, sounds good. Right? So let's have a look. So what are we trying to do? So these 2 steps are all sort of manageable, but transformation and visualization is a challenging bit, right? So let's have a look how we can do this. Now we need these 2 packages, gggraph and tidygraph. So gggraph, this one is gggraph. So it's about visualizing Tidy graph is about a data wrangling, right? So we think about gggraph as a ggplot for graphs, and think about tidy graph as a tidyverse for graphs. They use the same principles introduced earlier, and the best part of that is that they also allow you to use your very well familiar options and functions that you can get from tidyverse and you can get from ggplot. So let's have a look. We're going to have a look at a very short case. Well, it's not that short, but we're going to have a lot of fun with that. Anybody heard about Simpson? Simpson, the cartoons. So we are going to have a look at those characters, and we're going to do some manipulation. We're going to construct a graph, and we're going to look at actors, and we're going to have a look who is the main boss in the family of Simpson. All right. So again, make sure that you load your library. So previously we made sure that you install them, and now can you all make sure that you load them? So go to your RStudio. If you remember the exercise yesterday we did, so we create a new script, and in the new script you'll be putting all the lines, right? So do you need a refresher? I remember somebody was not on the computer with the RStudio, and I suggest using RStudio Cloud. So do we have any issues at this setup point? So are we all set? So I would assume that you are here in your RStudio, and let's say you launch up a new project or new project, right? And we're saying that we're going to use that, right? Whatever. All right. So you have your new project. All right, and you create your R script there. So which is you're going here. All right, and you create an R script. All right. So before we move any further, can we all acknowledge that we're all set, that we have our script open and we're ready to go? All right, just because if later people say, oh, well, I have no idea where to find that, and we're going back to a couple of half an hour, that will be challenging, right? So we create an R script, and this is where we're going to write. So at this stage, you should be able to install your packages. And now what I want you to do, I want you to load your libraries. So we are going to work with gggraph to start with, and we're also going to use some igraph operations, and we're going to use tidyverse manipulation, right? So can you all make sure, so I'm just posting it in the chat in case you don't have access to the file. Can you all make sure that you included these 3 lines in your R script? All right, now the data set that we're going to use is a Kaggle data set. Right, so let's have a look at Kaggle. So Kaggle is a fantastic platform, and if you haven't used that before, I really suggest that you have a look. So Kaggle dataset is a data platform. It's not data, it's a machine learning data science platform, which allows you to compete for prizes using your data analytics skills, using your data science skills. The best part about Kaggle is that you may not really be into a competition, but they provide access to some data sets, and those data sets come across various areas. Right? I've seen research done on Kaggle data sets, just because you know where the data is coming from. There may be some questions about authenticity of the data and clearness of the data, but usually those data sets are pretty good. So this is the data set that we're going to look at, right? So let me post that in the chat. That data set is just absolutely fantastic. Now, they give you quite a few files, all right? So quite a few files over here. we are going to use the last one. So we're going to use the Simpson script lines data file, right? The data file is quite big, so it's up to you. I'm going to show you how to work with the file. So it's better to download it and then upload it, but I also have a pre-saved shorter version for you, which we're going to cover later. So if you don't want to go through all the downloading and uploading, I suggest that you just wait till I say, this is the file that you go and you import. All right, does it make sense? So this is the original file that I'm using, and some additional steps, I suggest that you just go and have a look. They're not really related to like our main topic, but they're quite interesting. So what's in the data set? So Simpson script lines, right? So this is the data set that was scraped, right? So data mining, one of the data mining techniques. So what they did, they went through all the transcripts for all the episodes, and they created a big file with all the scripts for every episode. So so that's the data set. What are we going to do? So in my case, I downloaded that data set into my working directory, and I'm reading that CSV file, right? I don't suggest that you do this because like some people who knows how to do this, that's good. But there's people who are sort of not really familiar that well. So just wait till I tell you what to do, right? So I'm reading my file, and now if I have a look, so let's have a look how my file looks like. Looks like what's that? So if I just go like this, oops, where is my Simpson file? Oh, I think I have it open somewhere. All right. So this is my Simpson file. So this is my Simpson file, and this is how it looks like. All right. So I've got IDs, I've got episode ID, I've got the line number, I've got raw text, which I'll be working with. All right. Now I've got timestamp, right, and I've got all other details. Out of all the details, I've got quite a few things that I'm interested in. And let's have a look. So what exactly I will be doing with that? So raw text, who's saying what? And so what are they saying? And who is saying? All right. So raw text, and who is saying that? All right. Now let's have a look. So what I'm doing. I'm reading my file. I'm reading the full file, and I'm saving it as my variable lines. Now I want to filter that. So what I'm doing, I'm filtering. So I'm looking at raw character text, and I'm filtering those who only have something, right? So if there is nothing, like I'm just like, I don't really want to include that, right? Now, if I just start looking into my file, if I'm going to take every single thing, so let's have a look. That's a lot. That's really, 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 really important data. I don't really need that. All right. And if I start going through all of them, that will take a lot of time, and my graph will be very, very messy and noisy. Michael, I see your question. You don't need to download. That's what I'm trying to say. All right, so you just wait for me to tell you. I will give you the link to where I already pre-processed the file, and you will just need to load the pre-processed file. All right. I'm just showing you what sort of manipulations I done to that original file. So if you're interested, you can go and you can replicate, but probably like not now, just because you require registration. Right? Now oops, oh my gosh. Let's have a look what I'm doing next. So I'm going to limit my analysis to only characters in 20 recurring characters in those episodes, right? So I have a look what I'm doing. I'm taking my file and I'm grouping by my raw character text. So if you remember, so this is back to my original file. All right, so raw character text. So this is what they're saying, and these are the actors, right? So who is saying that? So have a look in my first manipulation using tidyverse. So what I'm doing, I'm excluding those lines which don't have a character, right? So somebody like you're leaving the apartment, something's doing something, I don't really need that, right? So I'm including only those who like actually saying something. So I assume that the most important person will be the one who talks a lot, right? So now let's have a look. So what I'm doing next, I'm trying to, let's have a look. So I'm grouping them, I'm grouping my data by raw character text. So who is saying what? And now I am creating a variable which is called appearances. So how many times they appear in an episode. So I'm using indistinct, so distinct appearance, and I'm using episode number, right? So in different episodes. So I'm going to include only those who are going to have 20 or more appearance. So if you appear only once somewhere in the episode, I'm not really interested. I know you're not important because there are some much more important people there who constantly appear in every single episode, right? Does that make sense what I'm doing? So I'm isolating my top characters, right? So top characters just to see like who are they, right? So they will be my actors. And now let's have a look. So I do have my top characters, and the next line. So what I'm doing on my next step, I'm trying to count character lines per episode, right? For those top people. So let's have a look. So I'm taking the list of my actors, the list of my main characters in episodes, and I'm grouping them by episode number, by character, and by episode ID. And then I'm just counting lines, like what do they actually do, right? So what they actually say, how many times they say things. So lines per episode, right, per each character. Now, so at this stage, have a look. So that I've done with my pre-processing, and have a look what I've done. I saved my file as lines per episode, CSV, and this is the file that is available for you to import. So I suggest that this is what you all do. So now, so this is linked to my GitHub, right? So where I have the file prepared for you, and I'm going to copy that link in the chat. So you can just take it from the chat, and this is where you start, right? Again, to be able to run that line without any errors, I'm using a read CSV, which is a function from tidyverse. So you need to make sure that you have library tidyverse loaded into your space. Otherwise, it's going to show you function not found, right? So I'm just posting it in chat. And this is what I want you to do, right? You don't need any registration, and you're going to get my pre-processed files for your further use. So this is where we're going to actually start doing things. So if you remember my my tidy graph, right? If you remember my tidy data workflow, what we've done, so we are at this stage. So we already done the import. So I did the import, the full data set, and I did some tidying, right? So you are not going to work with like the bigger one. So you're going to work with a shorter one, only 20 characters, and I already calculate like how many lines they're saying per episode, right? So you already have that. So now, can you all make sure that you are able to run the line in the chat with no issues? Because this is like really critical, right? So if you're not able to do, if you're not able to do that, so you won't be able to follow any further things. Yep, all good. So now that's the starting point. So this is your file. So this is your file that we start doing further things. So now we're going to work together with gggraph, and we're going to work with igraph, right? So we're going to use gggraph for visualizations further, but let's start with igraph, right? So first, what we have, so if you look at the file that you have, do you have, now let me have a look. So where is my project? So if you look at the file, which you just imported, Noor, what you have to do, you need to include a library. So what you need to make sure, that I'm typing it in the chat. So you need to make sure that you have library, tidyverse, that you run that line first. All right, so library, tidyverse. Can you just run that line first? All right, and then just move on. All right. Anybody else having issues? Bring it up. Okay. Anyone else have an issue or working for everyone? So next, what I need to do, I need to put like at this stage is just like CSV file. It's not the edge list, it's not the nodes list, it's not adjacency metrics, it's like nothing. All right. Tanjin, are you all good? Are you like a couple of other people mentioning something is not working? Are we all set? Again, I do have my students here, student helpers. They will be very, very happy to work with you individually. Just shout in the chat that you need some help. Amanda, so can you take them if they need some help?
Yeah, sure.
Right? Perfect. All right. So if you have issues at this stage, it's critical. So you have to say something in the chat. There are people who will look after you so that you don't, that you're not like lagging behind. All right. Now, so I have a look what we're going to do. The file that you have is a CSV file. The way for you to work with graphs is that you need to have edge list and you have or nodes list, edge list and nodes list ideally, or you have adjacency metrics. Now, in our case, we don't have it. So let's do this. So let's convert our data set into a weighted adjacency matrix. All right, and that adjacency matrix will show us character connections. Now let's have a look how we're gonna do this. All right. So in our files, we have lines per episode, and we have main characters who have 20 appearances in episodes. We're going to count lines per episode, and then we're going to use one of the approaches. We're going to use cosine similarity to weight connections based on episode appearances and the amount of how much they're saying, the amount of like communication, amount of what they're doing, right? Does it make sense? So it's one of the ways how we can weight the importance, right? So the more people talk, the more important they are eventually, right? So this is how we're going to assign weights to connections between whom. So let's have a look how we're going to do this. Now we're going to, guys, my AirPods are dying. So when you're not hearing me, you just tell me that you're not hearing me, okay? So let's have a look. I'm taking my file, lines per episode, and I'm looking at those lines. So I'm converting it to metrics. And then have a look at what I'm doing. I'm just getting rid of those parts which I don't need, right, in my file, because I don't really need all of the information there. And then I calculate the cosine distance between those characters, right? So let me post this in the chat. All right. So again, you can take it straight from the chat, or you can get it from my Markdown file. right? So this is really important as well. So this is the next step. So once you have your file, we need to convert it to matrix because it's not a graph yet, and you cannot work with your graph. You cannot do any of the further things. So it's all the preparation to get it imported as a graph. All right. So we are creating adjacency matrix, and we are assigning weights. All right. So can you talk to me? Are we all good? So a couple of people got stuck at that tidy verse at the initial point. Has been all sorted out. All right. So we just follow this. So like how exactly you prepare your data set depends on the data set. So that's why I'm not going into too many details here. All right. So we can focus on how exactly we'll work with our. All right. So you've got the cosine similarity matrix, which is good, and this is the matrix which is basically our adjacency matrix. So we are looking at connections between our characters. Right. Now let's move further and let's have a look. Let's do one thing. All right. So this is where, so like before we import anything, right? So let's have a very, very quick look. And for that quick look, we've got a fantastic function from not igraph, but gggraph. Autograph is a very, very cool function. So autograph is a cool function because it works with adjacency matrix, and it allows you to have a very, very quick look at what you have in your matrix, in your data. So have a look. Autograph is from ggplot, is from gggraph. So you need to make sure that you loaded your gggraph library, right? So if you haven't done it, it will show you a function not found. So we go library, gggraph. Daniel, I'm absolutely right. It looks horrible, and that's why we need to work with that further. If you just do it like this, it works, but nothing, like really nothing, right? So it's a blob. Oh no, so it may look a little bit prettier because it's sort of condensed here on the slide. It may look a little bit prettier on your screen, but it will be all very, very awful. But the point here is it's still awful, so we will be working with this, but autograph is a really cool function that comes from the gggraph package that allows you to have a look at your potential graph and see, is it like terribly horrible or a little bit less horrible? And what sort of work you need to do. All right. So at this stage, you've got lots of different nodes. So it's adjacency matrix that you're looking at. All right. Well, printed like Daniel. Daniel saying that he always wanted to get an autograph from Simpson. Printed. That's how they look like. And the whole family. And not only the whole family, but all those important actors in one spot. May look very similar. Right? So autograph is a cool function that you also can use not only for your graphs, but everywhere. All right? Let's move further. So are we all good? So we imported things, right? So at the next stage, right? So we are going to work with this further. This looks awful. Why do you think it looks awful? Anyone? Why do you think? Why do you think it looks awful? We need to show data, right? It looks awful because you have too much noise there, right? So even though we're trying to isolate those characters with 20 or more appearances, it's still not really. It's just like, yeah, exactly. So what's the message you're trying to say? It looks like it's like a white noise. So not really any connections, right? So just something, but it doesn't make any sense. Now let's have a look. So what we can do, even though, so we're looking at, so the first step, we looked at those characters that appear 20 or more times in episodes, but because the cosine matrix shows connections between actors. Some connections are very, very weak, all right? So those people are not really talking to each other. They're very from different universe. They are not really connected. Should we include them in our graph? Not really. So we need to get rid of them. So we need to filter our weak connections, right? So we need to look at the adjacency matrix, and we need to remove those weak connections, right? And then we probably need to start thinking about, we may have too many characters. What if we introduce communities? And what if we start looking at communities, like how we can look into those characters, and if there is any way that we can form clusters, right? So those smaller clusters, and in this way, so if we can use clusters, we can probably replace them and just use clusters instead of the actual people. So we are trying to reduce the number of things are happening in our graph. So let's have a look how we're going to do this, right? So let's first filter our connections, right? So we are not going to change our matrix, our object which we have. We're going to create another one which we're going to call strong connections, right? And now we're going to look at those connections that are sort of stronger than normal, right? So this is where I'm filtering them. Right, so I'm just putting this in the chat. Right, and I'm changing my metrics. So I'm from now on I'm looking at only at those stronger connections, and these are the ones that I will be working with later. All right. Now, next step is quite easy. So what I'm doing, I'm creating an igraph object, right? So I can create directed one or undirected one, right? Because who talks to whom, what sort of relationship they've got. Well, let's stay simple and let's do the undirected one. So I don't really care how they interact, right? But as long as somebody's saying something to somebody, and as long that other person can reply or may not, right? So I don't really care. So let's have a look. So what I'm doing, I'm taking my matrix and I'm saying, so you treat it as a matrix, and have a look. I am pushing it to my igraph function. So this is not ggraph function, but this is our igraph function. So graph from adjacency matrix, right? So again, because I'm using tidyverse and piping sign, I don't need to specify my matrix again here in options, right? So it's taking this object and piping it through, so passing it through to graph from adjacency matrix function. And I'm saying that I want an undirected matrix, but in this case, you remember we put on weights, right? So I really want to include weights. It will be weighted, and I'm going to use them later. All right, so that's my igraph object. So let's have a look. Oh. So. Right. So now I'm creating graph. Now, why do I need a graph? Because I'm going to apply a Levin method to identify smaller clusters. So smaller clusters there, communities, right, that I will be using later for my graphing exercise. All right, so I'm applying this function. I'm not going into details of the math, right? So it's one of the popular methods over there. So community detection algorithm. All right. So I am applying that community detection to isolate my communities. And now let's have a look what I'm doing. I'm changing something in my graph. So, and I'm using the igraph function for that. So I'm not using any of the ggraph or any tidy graph. I'm just staying with simple things which we did yesterday, right? So I'm referring to vertices, and I'm adding an attribute which we call color, and I'm coding my membership in the community as a color. All right. So now, if I look at my graph, I do have additional attribute for my vertices. Again, what are my vertices? They are my nodes. So my nodes show which cluster, which community that character belongs to. Does that make sense? Anybody? Have I lost anyone? So let's recap what we've done so far, right? So far, so we prepared, so we looked at our file, we cleaned our file, we removed all zero speeches, right? Now what we did next? We isolated characters who are more present in episodes, and we isolate them as those characters with 20 or more appearance. So we assume that they are not popular, but at least they're visible and you can remember them. Now we created our matrix, right? So how those characters communicate between each other, right? And now we filtered weaker connections. So we removed connections between characters that are not really that strongly connected based on communication happening between them. On the next step, we identified smaller communities using the Leuven method, and we assigned membership in a community as an attribute in our graph. All right, does that make sense? Are you still with me, guys? So anybody having issues with anything?
Yes, Maria, I'm just trying to help Tangent out with some packages. Is it possible for you to put us into a breakout room, please, so I can share some screens with you?
Savandi, can you create a breakout rooms and put Amanda there?
Okay, hold on. Aarti, maybe are you the host at this point, or?
Want me to? Yeah, I can make you the host.
Yeah, I think that'll be good. I have also been sending messages to Tanjim, and yeah, and maybe I was thinking it might be better just to follow now and then try out later, because Aarti, you've made me the host now.
Yes.
Let's see how many people are.
Yeah.
So is it that
No, just sorry, just for Tanjim. Sorry, like because
is it just to make sure, right? Just because we're just yet to come to ggraph, right? So do we need anyone else who are trying to follow and lost and not sort of quite trying to speak up? So can you speak up now? Because I'm happy to to put people in the breakout room with Amanda, and Amanda will sort out things for you. So we also have Trong, right? So you can, if you're at a different stage, my other student can help you with that as well, right? If you're sort of, I don't really want anyone lost, because otherwise the full all the time will be just wasted.
Yeah, Maria, at this point, I think it's only Tanjim, because she's stuck with the library tidyverse place, right? So, so yeah, let me do a breakout room.
So can you put Amanda and the gym there?
Just yeah,
Amanda,
I'll assign
Amanda
manually. Hold on, I'm creating one breakout room. Assign manually. And add a room. Oh no, we don't need to add a room. Delete room. Yeah, hold on. Assign Amanda and Tanji.
Yep.
Right, and open all rooms.
And if you can allow the screen sharing, please.
How do you do that?
I think that is enabled for everyone anyway, Amanda.
Okay.
Yeah,
All right.
yeah,
Thank
yeah.
you.
Just double check. If not,
Okay.
yeah.
Okay. If not, I'll send you a message.
Yes,
Okay.
yes.
Thank you.
Okay.
Right?
Bye-bye. Okay.
And Richard suggested a real cool thing. So Richard, do you want to talk about what you did? So you used size, right? So you use size to mark those connections that are strong.
Sorry, I just had to get my mic working. Yeah, all I was saying was with the with degree. So this is I was following along in the GitHub file. So just with the next step where you're looking at changing the size of the vertices to match the degree.
Yeah.
That degree function itself doesn't operate on graphs. So the IG graph that we produced.
No. Which one? Are you talking about the first one? This one, filtering? You were at the filtering.
No, this is actually this is a step or two ahead of where we are, is all I was saying.
Oh, okay.
So when we go to change the
well,
the
everything is like, yeah, so everything that you have here is sort of generated from data, right? So everywhere has evaluation to true. So whatever you're seeing here is evaluated like from real data, right? But yeah, thank you for your comment.
No worries.
Okay. Okay, so we're here, right? So do we have questions in terms of steps that we're taking? So steps are more important than implementation, right? So we need to understand what are we doing to be able to get to the technical stuff, right? So now, we added one attribute to our nodes, to our vertices, and that's our community membership, membership in a cluster. So now let's have a look how we're going to use this. So we're going to start plotting, all right? So let's have a look. I'm putting on my random layout, all right? And I'm using igraph plotting facilities. Now it's all sort of being, sort of cleaned. How it looks like? Well, it's still improvement. So if we go back a couple of steps, a little bit better, right? More colorful, but still, can you make sense of what you see in there? It looks very similar to what we did yesterday with French strains, right? So we apply different layouts, still doesn't really look that good. It's still messy. Again, it's just because I have it condensed here, it will look a little bit less messier on your screen, but still very, very messy. So now let's look what else we can do with our plotting and visualization. So this is where we're going to start with ggraph, right? So ggraph is really cool. So it works with layers, and it allows you. So first, compared to plotting using the plot function, when you have all the possible options and you sort of jibble it together in one piece, in one line, when you work with ggraph, you are trying to isolate those layers and work with different layers, right? So we're going to go through each particular layer, but at this stage, I think it's more about trying things and then seeing how it works, and then just going through that. So we are going to use geom edge link. So that's the connection between nodes. So it specifies how those nodes are connected. So geom, so everything starts with geom, right? So geom edge link. Now, next one, we're going to work with geom node points, which is your node markers or vertices markers. All right, and now we're going to work with geom node text, which is our labels. All right, so if you move here, so let's look. So let's move to the previous screen, and let's see how that's going to change. So you see all the labels standing in the way. You see all the edges are sort of just jibbled up, right? So all the, like, we do have those colors. You remember we assigned color, but it doesn't really look that beautiful, right? So let's see how using those additional layers is going to help us, right? So again, the idea is that you build your graph the same way as you build your data visualizations using ggplot, right? So if you're not familiar with ggplot. Jason, I see your questions about dynamic networks. I'm going to reply to your email about, I'm going to give you a lot of information about that. All right, but just like I do have some other people who don't really have that level of expertise yet, right? So like, just a little bit away, right? So we're going to build up our graph using layers the way that ggplot works, right? So ggplot works by identifying by using grammar of graphics when you try to identify different layers of how your graph or how your visuals are built. Now let's have a look what exactly we're doing here, right? So this is where I apply the ggraph, so grammar of graphics, and I try to isolate things happening here, right? So it looks like, by the look of it here, it looks much prettier. So let's have a look how I'm doing this. This is the ggraph function, which is very, very similar to my ggplot, right? So I'm saying that I'm like specifying that that graph, and now I'm going to use the most popular layout option, which yesterday we talked about enforced layouts, right? So when we've got the ball, we've got all the forces trying to push things together, right? So I'm applying it there. Now so that's my first, so that's my specifying, that's my entry point, that's my input. And then I'm including geom edge link, right? I'm saying, so I'm including all the edges, right? And now let's have a look. So I am including geom node point, and here in brackets I'm using aesthetics. So when do we need to use aesthetics? So whenever you have anything, any variable or any factor, as we have in this stage, coming from your data, you need to use aesthetics. So aesthetic mapping. So you map that color, yeah, that's the parameter color, will be linked to my, you remember I created that attribute, right? Will be linked to the attribute, node attribute color, all right? So this is where I'm specifying it. And all right, so now let's move next. So you remember I did have really yeah, big problem with my labels. They were all like putting things together, not really nice, right? So this is where I go to geom node text, and I'm specifying that for labels. Again, I'm using aesthetics. So usually people don't realize the difference between putting things in aesthetic mapping and not using aesthetic mapping. So whenever you have things coming from your data, they need to be put in aesthetics mapping using this bit here, right? And finally, I'm applying themes. And I'm applying, so for legend, I'm saying just no. So these two parts, themes and legend, they are extra. But have a look, my much better looking, right? I am back to normal world without airport. So I'm going to copy that line in the chat. Right. So if you can include that in the chat, if you can just get it from the chat and see how it looks. On your screen, it should be better because then you have a bit more space to play around. Oh, it's looking better for Daniel, which is good.
Maria, I'm also getting what Norman said, that yeah, that people are saying color error, in fact a color not found. Okay, and Charles has got it to work. Okay, let me see where. Yeah.
You need to make sure that
Oh yeah,
so on the
that line.
previous screen, like I posted in the chat, so like we are, so have a look. Those of you who are having issues, who are having error, so that error like infected color, object color not found. This is because on the previous step, so have a look, on the previous step, we are assigned, so we used V and reference to our graph, igraph object, and we assigned that attribute color to our nodes, right? So that color may not be color, so you may call it like something else, but this is the attribute which we're going to map. So if you use any other ones, so you can use any other ones, but you just need to map it back in your G graph. Does that make sense? So in this case, so look, it's one of the examples. So where we are mapping our attribute to clusters, right? You can do whatever, like for those clusters, we use our clustering algorithm. You can do that later based on size, right? So depending on like a particular data set, based on size, based on like, conditions, some other conditions which you have. But the idea is that it allows you to work very straightforward with those using aesthetic mapping. Just make sure that when you use that, because by default it will not be taken as a factor. Just make sure that whichever attribute you have, right? Just because it may take it like it may take it as a character. So whichever attributes you have, you make sure that under aesthetic mapping, you're passing it as a factor. Otherwise, you're going to have issues. Especially those may be the issue if you're using like numbers. All right, does it make sense? So can we all make sure that we Jiang, it's a warning message. It should be still be showing you, right? It's still, so it's warning you, but it's still showing you. All right. So it's good. So anybody, so are we all getting like a similar, nicer looking? So it's still not ideal, right? So it's still not ideal, but again, it's sort of, it's a little bit better than it used to be. So we're slowly getting there. Just go back to a couple of slides and have a look at that black blob which you have. So you know that in your plots, you can go back, you can use the back option here. So whatever you are generating, so whatever the plots you've got, right? So if you're under plots, you can use the back button here and go to the previous one and see like how things are changing for you. All right, are we ready to move on? Good. So now let's look. So it looks better. Now let's get back. Now we still need to do some adjustments. We are perfectionists, right? Don't get too far into that. You never get your paper submitted then. All right, so this should be a good point to stop, but let's do some further things. So now we so like that error message which we were receiving, all right, so let's have a look. So at this stage, we're looking at geom edge link, all right? So what we try to avoid overlapping, and what if we try to reduce boldness of edges? So this is the case when we're going to work not with edge link, but with edge fan function, right? And what if for vertices, like if you look at our vertices, so our edges, so like I don't really like that like blobby thing here, right? And now what I don't like for my edges, so like your size doesn't look right, right? And what if we just try to play a bit with a degree of centrality? So we're going to go through centrality on like a couple of minutes further, but let's think about like the importance of our characters, right? So let's link our aesthetics, right? So how we map things, how we present things, the data part with size, with link size and text, right? So we're going to use, so calculating degree centrality, be simple as it is done in R, right? So we're going to use degree function to calculate the importance of vertices. You're looking at the number of connections, right? I'm going to show you different approaches and how you can compare and how you can select the best measure, which you assume for yourself, right? But just be simple at this stage. So we're going to use degree function to calculate the importance of our nodes, right? And again, so we're sticking with the same layout, so we're not really changing it. So this is the force-directed method. You remember those like spheres moving it out. Perkman Reinhold, right? Takes me every time like a breath to you. Like German names are very difficult for Russian people. Okay, so let's link it. So again, so what are we changing? Germ link to germ edge fan, and we're trying to map aesthetics, right, to our vertices. So let's have a look. So this is where I'm changing it, right? So I'm introducing what I'm doing in this line. Can you tell me? So that's I'm introducing additional attribute, right? So I'm working with my igraph functions. I'm looking at my vertices and I'm creating a new attribute, which is size, right? And for that size, I'm looking at that degree of centrality. So I'm just saying, just calculate it, like I'm saying simple. So degree, and I'm looking at the graph, right? And then, so these will be another attribute that I will be using in my mapping. So let's have a look where I'm going to use it, right? So I'm still using, so graph initiates the graph, right? So I can basically, so just because I'm using grammar of graphics, so I can just leave this line. It will give me the empty plot, right? And this is where my like ground zero. Now my next one, so I have a look, I'm introducing my edges and I'm changing the way that they are presented, right? So I have a look. Whenever you use alpha, alpha is a real cool feature because it allows you to use transparency in your plots. This is really, really cool. So some of those lines, which are not really that strong, will be transparent, right? So now I'm using geom node points, and this is where I'm linking. So all my points here, so I have a look, I'm linking them to, so aesthetics mapping, right? I'm mapping size to the size as it's calculated using degree centrality. And I'm mapping color to my color attribute. So a size is mapped to size attribute and color is mapped to color attribute, right? So that's the new bit, right? And now have a look. Those are my labels. Oh, good. That's my theme. That's my legend. So let me post it in the chat and you have a go at that. So can you try this? Yep, so that's a good fix. Yes, so Richard, yeah, right. But in my case, it works. Maybe that I'm on a different version, so it picks it up automatically. That degree comes from igraph. Charles, it's still a warning, so it should work for you, right? Later, I'm going to show you all other ways how degree centrality can be calculated. There are different ways, right? So different ways. And we're going to talk about how we can compare. And hopefully we're going to have time for that. All right? So it looks better. What do you think? So what exactly, so can you tell me what exactly you're like, compare these two. So I have these two, right? And again, so you have these two graphs. So I have this graph and I have this graph. So what is the message? Again, so technically, like, yeah, I know that quite a few people are stressing out, oh, it works or it doesn't work, just give me a warning or something. But the idea of visualization is that we're trying to communicate the message. So what is the message that we're trying to communicate here? So this is, we use color. So what do we use color for? So we've got size and we've got color, right? So more important people are bigger, right? I can sort of no. It doesn't allow me to maximize my slides here, so I'm just on very, very maximum, right? So the bigger the size, the more important the people, right? And now I have a look, I'm using colors. What are the colors? Different smaller clusters, right? Smaller clusters that I can isolate. So who are those people? You remember there was a fantastic talk yesterday and they talk about isolating clusters, right? So you can like, you may consider that. So clusters based on what? So in our case, classes based on communication happening, right? So some people interact closer, some people don't really talk to each other that often, right? So you also can like potentially, so we've done a very, very simple, we just counted like how many times they talk to each other. At the same time, you may look at the language characteristics. So because you have a text, right? So basically you can cluster your actors just based on the language that they're using, all right? What else do you think you can do? Just what are the ways how you can look at just making your graph communicate the message? Charles, are you sure that you've got edges deleted? Because I'm using alpha, so it shouldn't be deleting like all of those edges. All right, so are you not having any edges at all?
I think, Maria, like, you know, even when I did it, the out edges doesn't really come in the little one. When you press zoom, it comes out much nicer.
You know that when you import, you use import export function, it actually stands out and you can have it maximized for the full screen. So if it's in here, so if you're in RStudio, right? So, and if you generate your plot, you play on Zoom, you either press Zoom or you can use export function. And when you start the export, it sort of brings it up. And this is where you should be able like to do whatever you want with your graph, right? But again, so we are talking about like connections are there, but it's a space problem because you're trying to put things in a very small space here in your plots, right? So the communication. So if you want to communicate, you need to say it loud, right? So you need to get your graph over at a larger screen, right? Now, like anyone having any issues? All working? Then Jim, how are you doing? You're back? Are you good? Have it been sorted out?
Maria, we had quite a number of issues, and Tanjim had also a problem with the microphone. So there's technical issues that that I couldn't assist her with. So I was just wondering if there's an opportunity in the break for you to just do have a quick meeting with her just to see if you can assist.
Okay, just let me have a look. We're just going to cover like a few more spots, right? how people feel. Sabanti, what do you think? Should we have a break now, or should we just finish up that example?
Let's finish up the bit, Maria. I think we can sort out Tanjim at the break. That's what we were thinking.
Right. So,
and right now she's
I think
following.
just giving the amounts. So we're going to get that break at the end. We have only 2 hours. So Tanjim, if you can stay behind, right, just during the break, we are very happy to have a look at that. Right. So, but let's have a look. So let's move on. So our plot looks better, right? So our plot looks better. Now let's have a look what else we can do. All right, so let's move on. But it's much better, right? You remember yesterday we tried all the igraph things and it still looked horrible at the end, right? So with all different layouts, still not really cutting. And people are saying, oh, well, is it, right? I better go to my other software packages rather than this, right? You remember there was a question, somebody asked Robert a question, so how he's dealing with a very complex. I really love that question. That was really cool. So how you work with your graphs that are very complex, right? So one of the ways is just like what he suggested, but you also can do this. So we're sort of simplifying it in a way that we're bringing the most important parts of our message. And this is where I want to start to pose you a question. So what do you think are the other questions? So what is our question? Our question was to present the network of characters and their interaction. So we wanted to bring up community. So we want to show clusters, and we want to show how those clusters communicate with each other, right? How they positions. And we also wanted to have a look at main characters. Right? So Derek, I'm glad that it's working for you, right? So I would I have no idea what other packages you've got installed and why degree was not working for you. But yeah, so a degree that we're using here is degree on centrality. Now let's move further. So the layout option. Now we're going to use another package here, just a little bit of extra. So it's not really that critical. So it's a little bit of extra that may allow you to put your graphs next to each other. All right, so I'm including here, I'm not really using it though. All right, so you can go without that, but if you use Grid Extra, it would allow you to put your graphs nicely next to each other so that you are able to communicate them in that way. In my case, I will be just going one by one. So let's have a look. There is no best algorithm, what's the best layout. It all depends on a particular data set, and it all depends on a particular what you have and what is the message that you want to communicate. All right. So I have quite a few examples here. All right. That I suggest that you try out. So I'm just trying out different algorithms for layout available at ggraph. Right. So I suggest that you have a look and then you select which one you like most. Right, so I will be posting them in chat. All right, so this is one of the layouts that they're using. All right, so somebody mentioned that Kamarikavai with French strains look better for them, so try this one. It's also quite a popular one. So we're generating quite a few graphs. All right, so we're saving them as visualization, and then you can use Grid Extra to present them next to each other. You can also save that object, right? So with G3, for example, I can save it, and I can have it somewhere on my computer. So I don't really have to go through. It's not a pain with ggraph, but I don't really have to regenerate those graphs again and again and again. So you can save them. All right, and now let's have a look at the third option. So what I'm changing there, I'm changing the layout that I'm using to present my graphs. Right. And now on the final one, so what I need to do, so I'm not putting it here because again, on my slides, it will not really look that nice. I'm going to use a grid extra library. So what you need to do, it's an extra library. It allows you to put your graphs in a nice grid way, right? So you need to install it. So that was in one of the earlier slides. So install packages. So we're going to install Grid Extra. I'm just putting it in chat. So install that package. It's a cool one. So you can use it for different options, not only for graphs. Right, and just make sure that you load it as a package. So you load it as using a library, right? So once you generated these 4 plots, so those plots will not be displayed just because they are saved as a data visualization object, right? So now what we need to do, we need to present them next to each other so that we can have a look at them in a nicer way. So usually if you generate your papers, this is the way how you usually present it to your reviewers, right, to your stakeholders. You may want to create a markdown document where you will be using as a way to communicate the message you're trying to say, right? Now, and finally, so when you install those libraries, we need to arrange them. So for arrange, we use grid arrange. And again, I'm putting this in the chat. And you are specifying all the objects that you're using. And we're saying that I wanted 2 per row. Yes, I'm just copying it here. So make sure that you generated those G-graphs first. Which one like better?
G4, I think.
G4?
Yeah.
So G4, like you see, like this is where, so it's G4 for strong. So you see, this is where you're beating the common approach, right? Because the default one would be the one which we used, Friedman-Reynolds, right? Now, but yeah, so this is where you have to try different things. And this is the beauty. So it's science and art, right? But it's good to have those options. It's still much better than igraph. All right. So now let's look. So, but like it's not again. So this is like we still can do some further things. What do you think? Sky's the limit, right? So let's do the next bit. So what we can do now. So let's again. So we were not playing. So here we were just staying. So guys, have a look. So we were just staying just with basic geom edge, right? So geom nodes. We haven't used any themes. We haven't used anything with legends. We haven't actually looked at those things as well. So that gives you additional flexibility in terms of your color choice, in terms of like where things are, how you explain things, where you position things, right? But it's still much prettier. Now let's have a look at the next thing. So we're sort of moving closer to the end of that example. And let's have a look, so what else we can do? Now we can use filtering. all right? And with filtering, so just because we've got that aesthetics mapping, so IS, so we can use IS mapping to highlight a particular areas that we want attention of our reader, all right? So we can chat filters, vertex size. We can remove color and labels from less important characters, right? And now we can use colors and set them directly if we don't really like them. So let's look like where exactly we're going to change this. All right. So again, note, so even though we did our clusters, even though we did our degree of centrality, so we changed the size, all right? But have a look. It's still visible here, right? So it's still visible here. What if we try to get those less important characters and we try to sort of not them disappear, but be less visible, right? So they will not create that color block, right? So they will not create those like noisy things. So we're trying to isolate, to bring like more important things back to us. So let's have a look how we're going to do this, right? So with filtering, so we're back, and we're going to change. A few things here. All right. So what are we doing? We're going to change. You see, like we're back to our filtering when we did it, and we're going to change our filtering part here. All right. So how we're changing this? We used to identify strong, right? So we identify strong connections. And now what we're trying to do, we're trying to identify those weak connections, because these are the weak part that we're going to sort of get rid of. Strong part is good, but you don't forget to cut out the weeds, right? So don't only like just water your plants, cut out the weeds. So let's do this. So we are looking at our cosine similarity matrix, right? And now what we're saying that we're creating as a copy, right? And that's why I was keeping it like as it is. And now with that weak copy, I'm trying to isolate my weak connections, right? So let's go with this. So it's just very, very similar to this, to what we did previously. But in this case, it's just the opposite. I'm not identifying the strongest one, but identifying the weakest one and getting rid of them. Right? So run this. This is last bit. It should look prettier. Yeah. So yeah. 6yen, yeah, so if you do grid arrange, so that's what I put in the chat. So you can put them next to each other, and you can have a look at them on one go. All right, so they will be arranged in a like I'm suggesting and row 2, so that they are two. If you want to have more, you can use as many as layouts as you want. All right. So now we're moving on to further changes. So we're going to filter our weak connections. All right. So I have a look. We're creating that new matrix. All right. And now let's have a look. So we're just like here, we're running this. We are creating a new new graph that we're going to work with. So I'm just copying it here. Again, we're repeating all the steps which we've done previously. So we still have, we're creating our graph of adjacency matrix, which that new one, which we created without those weak connections. Right? It's undirected this stage. Can you imagine all the fun that you can do with directed? That would be really cool, because you have arrows and you can play with your arrows for your edges, right? But there's two things: arrows add noise, right? So there'll be some further things that you can do to get rid of those arrows, and you can play with all the size and all the style that you use for your arrows, right? So let's have a look. So So I'm just posting in chat what we're doing. So hopefully everyone created that cosine week. I think, Case, I think what you're doing, you're not really installing that library, right? So you are trying to install some other libraries. Amanda, if you're still around, it's wrong. Can you have a look at Case? Because he just needs to install Grid Extra library, but
Yeah.
he's trying to install something else.
Yeah, I can help him with that.
Mhm.
You can put it with me in the breakout so we can share screen.
Yep. All good?
No.
So, please, can you just do this? Install packages.
Yep.
And you need to put Grid Extra.
Right.
So install packages, Grid Extra. You just need one more package. And you can run it into your console, right?
Yep, I'm gonna do that now.
So do this and then just do library, Grid Extra. So I'm just putting these 2 lines for you in the chat.
Yeah.
All right. So everyone else, how are we go? So we created, so have a look. So we just basically, so this is our new metrics that we're working with. So we are creating another variation of our metrics, right? And now we're creating our graph object. And now we're just basically doing the same step. So we are using centrality and we are creating additional attributes, but in our new, so this is our new graph, right? So a new graph. So these are the nodes, this is the attribute for our nodes. And now what are we doing? We are creating, so just because everything's changed, so we need to establish new clusters, right? So some of those members are not there. So that's why we need to run that Leuven method of clustering again on our data. And we're establishing some new communities, so new clusters. So then we're basically repeating the same step. So we are creating another attribute for our nodes, right? Color, it's still the same, but the membership is likely to be different because some of those members, they don't exist. Right? And now let's have a look. So this is the bit. So let's have a look. So let's have a look what we can get at this point. Right? So again, you can save it to G5, or you can just go straight and just generate the graph using ggraph and just have a look how it looks like. Right? How are we going? Any issues there? So can we, like, this is a really, really interesting thing what we're doing here, right? So I have a look.
Marie,
This
can
is
you,
sorry?
Sorry to interrupt, can you copy and paste the previous set of lines as well before the G5?
I think, yeah, so I can do it just in one go, right? I will just do it like the full thing. Because there was some like communication in between, so it's quite difficult to choose it out. So there's some quite interesting things happening on my ggraph, which plays up that ggraph library compared to what we could do using the igraph plotting facilities. right? It's really, guys, it's really important that you run a graph so that we can have a look at how that's changed now. All right. Keys, are you all good? All right. So let's have a look. So what exactly changed, right? So why it's a spider web? Now let's have a look. So what are the cool features that we are using here, right? So we established that graph opt was the best looking one, right? So we're sticking with the best. All right, now let's look. So we're sticking in that part, so with the best one. Now have a look. What's happening here? Geom edge link. All right. So you remember in the previous one, like if you go back, we're not using it. All right. So what is we're setting here? We're setting transparency. Right. So alpha setting transparency. Now, and have a look. This is really, really critical. So this is where you're setting transparency for the whole thing. And when you use aesthetic mapping, you are getting you're setting your parameters based on the data. So this is critical. So if you want just apply, like usually my students have that problem. If they want to apply color based on something, they just go straight color and they just blob it, right? So this is going to change your whole graph, right? So in this case, we're changing transparency for the whole graph. Now, when you start using aesthetics, you actually ask your plotting facility, your plotting function, to have a look at your data and map a certain parameters to what they have in the data. So I have a look. Now we've got two geom node points, right? And somebody is mentioning that spider web, right? So geom node point here, and we've got the same function here. And you say, oh, it's the typo. No, it's not a typo. It's just like different layers that I'm applying one on top of the other, right? And you can apply as many layers you want. So you can do the third one just depending on like what you want to have. And this is the beauty of that layering approach, because every other layer just comes on top of what you have. So let's have a look. So what I am doing in this option here, in this layer. So this is where I work with my edges, right? So I'm just saying that I want my edges to be sort of like transparent. Now, this is what is happening here. This is where I'm referring to my nodes, to my vertices. And using aesthetics mapping, I'm mapping it back to the data, right? Now, I'm saying that this particular function will be applied to a certain data subset, right? So what is that data subset? So you remember size, so we have got my size. My size is based on degree of centrality, which is the attribute for my nodes, right? You remember the French data set? I could apply there as well. So in that case, I could calculate centrality for my stations, right? And I can just do the same, so to make my graph look prettier. So in this case, I'm saying that sizes, so if my size attribute is less than 50, right, then the size of my point, right, of my like a node point, like how big is my dot, will be the size, but I'm going to use transparency, alpha. Does that make sense? So what is it saying? That a less important one will be more transparent. All right, and I'm still using the size. Now let's have a look. My next layer is the same. So I'm going back to my nodes, and that's what I'm saying. So those that are bigger, that are more important, all right, just based on that attribute, based on degree of centrality. Now, what I want them to do, I want them to be
of a color. So important ones will have a color. But you remember what color is saying. Size is saying how important the character, but color is saying where that character belongs to. Which community, which cluster that character belongs to. Does make sense? So I'm playing up important actors in a community. So I'm communicating two things. Are you guys, are you with me? Or is everyone on lunch already? All right, perfect. And so this is if I need to add another layer, I can do this. So in this case, again, I'm working with the size. If I want to include any other, so okay, when I have directed, so you've got, so this is where I'm looking at nodes. You can start working with your edges as well. So you can show stronger connections. You remember, we have weights. We did establish weights, we did calculate the weights, but we haven't used it, all right? So we can, like the next iteration would be to look at our weights and to play with our weights. All right, now the next part, so what I'm saying is that so node text. Again, so what I'm saying that I want to apply labels only to more important characters. So those characters that are critical, well, it's called critical for the movie, they are going to have labels. Other than that, they're not, right? And again, so here, I'm not really doing anything with themes. I'm not doing anything with my legends. Well, the only thing that I add is just like a one thing extra. So themes are here and a legend, as well as my title and all like very, very visual part of how my graph actually presented, all the annotations comes from ggplot. So if you're familiar with that, it's just like straightforward copy and paste functions from your ggplot. So that portion here is specific to ggraph. That portion specific is what they take from ggplot. But what they're saying that everything that comes from ggplot will be, if it's applicable to graphs, that's implemented there. But the big question is what is applicable, right? Now, are we happy to move on? So let's have a look. And now finally, so let's do some more changes. So let's change color. All right. So what are we doing? I think it's the last change that I'm doing. Yes, it's the last change, and then we'll probably break in. What do you think, Sarandi? Because I've got my measures and like all the measures, and I'm going to tidy graph.
Yeah, I think that's good. Maybe we can do that, and then yeah, I think that's great. Yeah.
Yeah. So
I was going to ask at the end though, like yeah, I'll ask that at the end.
Do you need any announcements to make?
No, we don't have announcements. I just want, yeah, maybe just ask people who haven't filled that form to fill it out. But yeah, I've got this other thing that I wanted to ask and just inspire discussion, like in a small one. Yeah, but I'll get to that after you finish it.
That sounds good. Now let's do the last variation. So we're going to change colors, right? So we're going to change colors for the Simpson family. Now let's do this. So we are back to our igraph object, right? So far, no, if you remember, so we've got, so that's our igraph 2. We are back to the original one, to the one with main characters. You remember? So the one which was played up the strongest connections. So we are making a copy of the Simpson family. And now we are assigning the color gray, right? So, and now let's have a look. So we are working with the color. We're changing, we are assigning that gold color to whoever character starts with, includes Simpson. So that's just the color for the Simpson family, all right? So you're gonna have all the characters, but in this particular case, we are looking at names of our characters. And if the name includes Simpson, then it will have a special characteristics, which will be gold. How does it look like? All right. So this is like it may be. So we identified our communities, we identified our clusters. But now on top of that, we have we are putting a new rule. So it needs to be part of the Simpson family that we're going to look at. Now let's generate our last graph. So let me put this bit in the chat. Right. So everyone else will be gray, but the Simpson family members, they will be gold. Because there are no other people than Simpson people. All right. So the color is changed to gray, but all characters that include Simpson in their names are going to be gold. All right. Now let's have a look. So we're putting this in the chat. I'm putting this in the chat. So I'm putting this last graph. So we want to identify where the Simpson family sits. All right. So I'm simplifying it a lot. I don't really want, so the message I'm trying to present here is very, very different. So one message was for the previous, so what was the message for the previous graphs? What are main clusters, how they're connected, who are main actors, all right? But this one, it's a different message. So you always need to go back what exactly you want to say with your graph, all right? Is it the communities that you're trying to pull up, or is it the family? Like in this case, I don't really care. I want to show just interaction between family members, Simpsons, and everyone else. And I want to show where they sit. So let's have a look what I'm doing here. So G-graph, so that part again, so I'm just make sure that you include, that new simplified. Yeah, so you're quite right. Yes, you're quite right. It's much simpler, but this is just because I don't really want to have complexity. Accuracy is never a point. Well, it should be. It's important, but it's not important for the message that I'm trying to present. All right. So you always need to start with the message, and this is where you'll always forget. So they usually have piles and piles of data, and they try to squeeze that data on the graph. And when they squeeze it out in the graph, they are horrified because it looks horrible. Well, no wonder, just because you don't have a message, right? So think about what exactly you want to say with your data, right? It's a work of art. So let's have a look. So we are working with that simplified graph. We're having the same layout, personal element, right? And here, so we're setting transparency for our connections. Right now, geom not points. So what we're saying, we're going to use size. So we're mapping it back to our size. So you remember, we're taking size as our degree of centrality. And now that color is adjusted color now. All right. So we're taking it from vertices of that new data set. All right, and color, gray and gold. All right. And now what else are we doing? What else are we doing? This is also, so we're applying some further filtering. So what are those, what is the filter that we're applying?
Just the Simpson name. So whoever
yeah, so we're applying, so we filter by the name, right? So we don't really whoever is not the part of the Simpson family, we don't really care. So grapple is a really cool, is a cool function. All right. So we're looking at the name, which comes with a note, and we're filtering just based on that, right? So, and if you're part of the Simpson family, then you have your size, and then you have your name. Right? And everything else is just, so you have this, right? So what do you think? Yeah, so then that's like very strong message that Simpson are the heart of the movie. If you take Simpson away, there probably will not be any movie. All right. So all the communication, you remember. So first, remember what you're trying to show. So we're showing communication. Will be quite interesting. So if we change our target, we change our focus, we can look at language, how language how it plays in, right? What are communication groups that you can get? Right? And if you saw, a couple of people ask about additional things that you can get. Now, somewhere at early start of my slides, I've got reference material for every yeah, it's start together. So the best thing, so the person who developed, so the best thing for you to start working with any new package will be to start with the CRAN. So CRAN for Ggraph, they do have quite good vignettes, right? So these are the vignettes. So how to work with edges, how to work with layouts, how to work with nodes. All right, so they also are a good vignette on how you've got your tidy graph working together with Ggraph. And this is what we're going to do in the second part of the tutorial. So we're going to look at how you can implement these two and how you can make things not only look better, beautiful, but how to make the workflow easier. So I'm going to post it in the chat. Now, your particular question about themes, right? So themes come from ggplot, right? So all the themes options. So here, it's only what relates to Ggraph. Apart from that, you've got ggplot. And ggplot is just a total big domain where you can do a lot of things, all right? So if you're interested about using particular parameters for your themes, these vignettes will be the best way to start, because this is like a sky is the limit. You can do whatever you want. They also have so if you go to RStudio has very good cheat sheets for ggplot, which I suggest having a look at. Not everything will be applicable to graphs because they usually work with linear tables, right? So it's quite difficult to put that. But all the themes, legends would be applicable. So if you go, so ggplot, if you go just to the RStudio Cloud, RStudio Cloud has all the cheat sheets and the same things. I'm going to, we're going to go through additional resources, but that's somewhere back at my slides. So ggplot cheat sheets. They are at our RStudio website. They don't have cheat sheets for Ggraph, unfortunately, yet. But the part which is over here, later part, may be useful. So when we talk about themes, we talk about like all extra themes available for ggplot are applicable here as well. All right. I also have, so if you go to the GitHub, so I also have some materials over here. which says igraph. Right, and this is like a more manual type of thing when I go through every single option, every single parameter, and you can have a look at that as well. Right, but I thought like for the case of just we have 4 hours, but like yesterday showed that 4 hours is not really enough. All right, so you can have a look at that as well. All right, so we've got 5 minutes before the break. So after the break, we are going to have a look at further. So we're going to have a look at some further graph measures. So, and with graph measures, we are eventually, so we'll have a brief review of what can be done. And then later, so we're going to, so this is like what I was talking about, like how we can compare different centrality measures that we can use and which one will be the best one for you to use. Now, like I do have a small case study for us to have a look. And I also, but I'm not quite sure just how we go with time because I've got very, very different levels for participants. So I was planning to go through a Twitter data set and see like, I was amazed. Like Robert is doing a very similar thing as what I was planning to do for our small case study. Right, so we I wanted you to have a look at Twitter, just get some feel of how you get your data from Twitter and how you put your Twitter data in a graph format. But let's see how we go. If we don't have time to cover this, all right, I will include those files at my GitHub repository so that you can have a look at that example. Quite interesting. All right, so Andy, what do you think?
Yes, very great. I was also wanting to like, you know, see what you would think on because this on igraph. So this clustering techniques, we've done the cluster Louvain, and then there are other clustering techniques as well with the igraph. So if you like, you know, on this link on igraph if you scroll down, there's heaps of clustering stuff and how, like, you know, because people were talking about the clustering where one Simpson was in a different cluster, like, you know, because that is a function of the clustering technique. And then how, which clustering would suit this example better, because each of them are minimizing some kind of cost function.
Yeah, you're absolutely right. We just went with just showing that classes can be done and classes can be applied. We're not really like building up a lot of theory around that. So again, so you wouldn't really do that with your data, right? So you wouldn't really apply it. Like you guys, you see, you saw the same thing with your layout. So the layout, which supposed to give you the best option, was not really the best one, right? And that's the same with clustering. So you like it's with every research. You cannot just go and apply what other people did. So you need to have a look at your data and you need to have a look at literature around your domain area. So what works for one domain area may not really be applicable into others, just because different types of connections, different types. So, and again, these, we were looking at interaction, so who's saying things to whom, right? Kids may not work, you know, kids, parents. So like what sort of theory you want to build around that? Kids not talking to parents and kids talking to TikTok, right? So who they talk to? So it's different. Again, so this is the different things that you are trying to identify in your data set.
So Maria, would you say with gggraph and tidygraph, they're more for plotting and things, whereas igraph has more like, you know, the theoretical stuff that you can, you know, is that that or not?
igraph is a little bit simpler. I would say statnet is like a really big one. It's about, so it's more, it's what Robert mentioned yesterday. It's more about combination of things, right? So you take one, and that's the beauty of R. So you can take more classical approaches, more heavy lifting from statnet and igraph, when tidygraph is not really giving you some totally like new measures, right? So like they're implementing some simpler things, but at the same time, their strong point is just because they allow you to work better with your data. They try to make your time efficient concerning your data wrangling. So all the data manipulation. So we will be looking at, I couldn't really pass tidy graph. The way that they work with the data is just like amazing, right? So how they present those edge lists and how they work with matrices and how quickly you can change you can switch from one data to data set to another data set is just amazing. So, and filtering, applying, like, you know, it's just the same thing as compare your C++ with tidyverse. That piping is a lifesaver when you have to use, when you don't really want to stress about like running like loop again, right? It just allows you to work with the data. So that's the same thing. So Case, I think, okay, so if that was the degree, so you are likely to have some other package installed on your computer, which sort of overrides the function. So what you need to do, you just need to use igraph. All right, so just try this one. Igraph, oops, you know, auto change in chat is just something.
Yeah, I think the Derek's trick worked to force igraph.
Yeah, it's just like have a look. So the only like what I'm doing here, I'm just particularly referencing that I want to use function from this particular package.
Okay.
Right,
yep.
And then just put like everything is the same.
All right. Thank you. Thank you, Maria.
Maria, there was also another question at the very beginning that the HTML file, we only see the text, like, you know, how can we?
I'm going to include like a normal link. So like a Sivanji. So if you can like today send email to participants with all like the slides in a way that they look on my screen, that will be fantastic. So that they don't really have to go through IMD or HTML type of like code. They just have a look at the slides.
Yeah. So, okay. So yeah, I just copied and pasted and saved as an HTML. I think I can't remember who had that question originally, and I said, okay, let's work it out later, because you know, someone had the question. Was it Jason? I don't know. Someone had it in the originally. Yeah. Yeah, so we will send it later. Yeah.
Okay. Yeah. Sounds good. Right. So guys, so let's have some lunch.